Okay, so we're going to write the equation of a circle first. This is going to be the easiest, or should be. So the general form for an equation of a circle, you've got your pink sheet as reference there. It's, oh, I'm not going to like this. It's H.
Why is it so skinny?
I don't like.
I can barely read it.
I don't like this at all. I'll make it thicker here.
Intro, I think. That's what he's putting your videos.
Yeah, I listen back to Honors Algebra 2.
I do not like this slate at all.
We'll go back to the hosters. I'm gonna use this host. We're gonna learn some X-rays.
I'm gonna have to switch to this. Oh, a laser.
Yeah, why is it?
Oh.
That'll make you really have to write down that stuff.
Dude, I don't.
How can I make this thicker?
I don't need that.
Marker.
Yeah, why is the line?
Oh, that's thicker. I thought it would be.
But
even
why is the
thicker.
dot so big and then it's just?
I don't know.
I hate
Can you
it.
read that better?
No.
We can read it.
No, it just looks so skinny. Like I feel like I have to squint.
You can't read it.
Yeah.
I feel like there should be a way to make it dark, like thicker.
Like that on a graph would be horrible.
Yeah, I agree. All right, so we need to plug this in. So where are these two going?
The H and the K.
So it's going to be x, good, squared, plus y, good, squared. Then, we got to remember how to square this. So when I square that, oh, this is awful. I'm going to square the 4, so 16. And what happens when I square that?
Multiply.
I multiply, and what is it?
2.
So I multiply 16 times 2, so 32. There's my equation. Yeah. I got distracted, I think. So that should be r squared. Thank you. So let's have you try another one. Let's have you try a circle with a center of 4, -1, and a radius of 5, square root of 3. I'm going to see if that this thing is hooked up to it, because I cannot stand that.
Oh, yeah. You can do it. I believe in you.
Well, I might have to, because this doesn't seem to be popping up. It's not. I'm just gonna have to stick with it.
You can't make it thicker.
I don't see how.
I feel like thin looks good.
Yeah. Try to use the marker one. See how big it is.
That is the marker.
No, the big one next to it.
This, the highlighter?
Yeah.
Oh god, no.
No.
That was a pretty line.
All right, so we're gonna have x what?
It's like lagging.
I know. That's what I can't stand.
Oh, because it's weird for you. You can't see how you write. Bless you.
What'd you get for the radius? 75, because it's 5 squared times 3. Okay, we're gonna move on to the tricky ones now.
They're all tricky. I'm gonna leave my
So we're not gonna do parabolas, so that's some good news. So we're gonna skip parabolas. So I'm gonna skip parabola.
It was very pretty.
We're gonna do an ellipse. So an ellipse, what I would do, you're not gonna have to graph this. I just put a graph there for a reference. Is I would put focus, and I would write them next to each other. So I would put, bless you, I would put 1, 2. Oh, it lags.
Why does it say right and equation?
I don't know. 7, 2, and 1, 2. And then I put CV for co-vertices. Way too much lag on this. 4, 0, and 4, 4.
You know, we fought for you to get that, so please act a little bit more like you like it.
I love this. It's going to be such a great adjustment. All right, so
Over to that permanently?
unless they find something better.
I know.
So
What's wrong with the other one?
1, 2. I'm going to have to use it till it dies, just like my MacBook. 1, 2, and 7, 2. So you don't have to do this. I'm just giving us a picture of what we have here. 4, 0, and 4, 4. So this is kind of the information they've given us. And somewhere in that information, we have an ellipse. And we have to write the equation. So what do we know about an equation for an ellipse?
It's
It's addition, so I know that.
X minus h squared over a squared.
A is always bigger than B.
X is always first, so I can do what Ella said. I can start it as, I'm just going to put this as reference. What?
Oh, that's confusing.
So I can start this, but what does change? The A and B or the B and A. So I'm not quite sure which it is yet. But I bet I can gather it from this information.
I bet we can.
So how? So the covertices are along this axis, along the Y. The foci are along the X. If the foci are along the X, what else is along the X? The vertices. So the vertices are also somewhere along here. If the vertices are along the X, where's the A go? It goes underneath the X.
It's 4.
We don't know what number it is yet, but if the hang on. If the vertices are underneath if the vertices are along the
Yes. 4x.
or horizontal, if they're this way, then this is going to go underneath the X. Thank you, Bailey, for trying to bail me out. And so that means it's this one. So I know that much. Ella, what's 4?
The A.
Not the A. Something's
B.
4.
Is it H?
So the H, because look, isn't right here, isn't this my center? Because when I look at my two covertices, it's in the middle. When I look at my two foci, it's in the middle. What do I call that?
Center.
True. But if it's between these two, it's the midpoint. So why don't we find the midpoint?
Let's do
What?
that.
Do I have to find it of both of them?
No.
No, just of one. So I'm just going to take the first pair and I'm going to find the midpoint. So I'm going to find the midpoint of the foci. You could use either pair, doesn't matter.
Why can't you just say it's
We'll get to that in just a second. You're right. We'll get to that in just a second. So I'm going to say it's 1 plus 7 divided by 2 and 2 plus 2 divided by 2. So the center is 4, 2.
I said the center was 4.
You just kept shouting 4.
I knew something was 4.
Okay. Now, Zoe, what were you...
Watch it be wrong when you stop there for nothing.
No, I don't. I think she was right. What were you trying to say?
I was gonna say you could just say it's 4 2 because in the covertices the 4 is in both of the X spots and then in the focus the 2 is in both of the Y.
Okay, so in the covertices, the X stays the same. In the foci, the Y stays the same. So if you recognize that and you see that, it is okay to pull that out as your center. So I'm okay if you don't show the midpoint work. But some of us aren't very good at seeing that, and so you're going to do the midpoint every time. Sometimes, depending what they give you, if they give you the if they give you the vertices and the foci, you won't be able to do that. You'll have to find the midpoint. So this always works, finding the midpoint. Sometimes you're able just to look at it. Okay? All right, so we have the center. So I have my H and my K. What else do I need?
A and B.
I need A and B in order to find my A squared and my B squared. Well, what's A tied to? The vertices. I don't know those. What's B tied to? Covertices. So I know.
2.
So I know this is tied to the B. Ella, how'd you come up with 2?
Because it's halfway in between 4 and 0.
Okay, so this is what we decided was the best last period. I'm going to take one pair. So pick a pair to compare. So the center and one of the covertices. And for people that didn't see it very well, it was helpful if I kind of lined them up. So 4, 4, one of the covertices, and the center, 4, 2. These match, so I ignore them. These don't, so I subtract. So I do 4 minus 2. That means my B is 2. I don't need to see that. But some of us, again, aren't so visual, so it helps to have that. I do need to see that your b squared, oh, it's going to take me a while to get used to this. Your b squared is equal to 4. So I'll need to see your center. I'll need to see your b squared. What else do I need?
Not see.
Well, we said a squared, right? So we don't have it. But if I find c squared, could I then come up with a squared? Yeah. So foci are tied to c. We're going to do the same thing. So I'm going to take 7, 2. Some of you see it, and that's fine. And I'm going to take 4, 2, the center. So I'm going to say c is 7 minus 4. So c is 3. And if you did that without any work, that's fine. Bless you. So c squared is 9. All right, so now we need that little equation. C squared is equal to a squared minus b squared. So we're going to have 9 is equal to, I don't know, so a squared minus 4. Bless you. A squared is equal to 13.
I'm so lost.
Okay.
I'm not gonna be able to remember this all. It's problem.
So I've got my a squared, my b squared, and my center. Let me put the whole equation together and then we'll go back through it. So I'm going to put everything in here. I need the center, the b squared, and the a squared. So I'm going to have x minus 4 squared over a squared, that's 13, plus y minus 2 squared over b squared, which is 4, equals 1.
I just think it would be less confusing if it didn't have all the work that you said we did.
Okay, so let me try one without that work.
We didn't have to do all of that.
Well, you have to do all of that. So the goal is to figure out which kind of equation you need. Figure out, okay, what do I have? So when I go through it, the first thing I always do is I figure out my center. Sometimes I show work, sometimes I don't, depending what I have here. Then the big thing as you're getting ready for this test Friday is to know, okay, vertices are always with the A. Co-vertices are always with the B. Foci are always with the C. Those 3 things are really important to know because it helps you not only graph, but now it helps you write equations. And so that helps you figure out what you have here. And then you're kind of working backwards.
Can we get that index card on the test?
Nope.
Please.
No.
It's a half an index card.
No.
You can cut them in half, and we'll just get a half.
No. All right, let's try another one. So let's try an ellipse.
We're gonna boycott this test.
Well, good luck with that. This time we've got vertices at -3, -4, and -3, 6. And I'm going to give you co-vertices with it. -7, 1, and 1, 1. Okay. So the first thing I like to find is I like to find the center. Some of you are going to look at that and you're going to know what the center is. Great. Write it down. Some of us, that kind of blows our mind. We're not as visual that way. That's okay. The center is the midpoint of any 2 pairs they give us, whether it's vertices, co-vertices, foci. So I'm going to find the midpoint of any of those pairs. I'm just going to take that first one. So the midpoint of this pair, -3 minus 3 divided by 2, and -4 plus 6 divided by 2. So the center is -3, 1. Are we okay with that? If you did it without work, you had -3 stayed the same, 1 stayed the same. So that's how you can kind of visualize that depending on the information they give you. Vertices tied to which variable? A. So we're going to be able to find the a squared this time. So again, you can do it without work. You can kind of say, okay, if I look at these 3 points, let me see if I can use this laser. If I use these 3 points, what stays the same with these 3? -3. So I want to say, okay, how do I go? 5. Same difference between -1 and 4. That means my A is 5. That means A squared is 25. Now, if I've just lost you, here's another way to do it. Take 2 of those points. So I like to use one with a with a positive if I can. So -3, 6 in the center. And I subtract the ones that are different. So I did 6 minus 1. That's another way I can get the 5. The covertices are tied to which variable? B. So I know this is going to give me my B. What's staying the same in those 3? 1 stays the same. That value stays the same. So now I'm comparing either these 2 or these 2. Well, what do I do to -3 to get 1? 4. There's a difference of 4 in between those. -3 to get to -7. I have to go 4. So my B is 4. So B squared equals 16. That's probably as much work as I would have shown if I were doing this problem. If you're lost on how I do it without the work, here's how I can do it with the work. I take these 2 and I do 1, 1, -3, 1. The 1s stay the same, so I would have done 1 minus -3. Well, I end up adding it and it's 4. Have I lost anyone in these values? Is that a little...
I know how you got there, I just don't think I can do it on my own.
With practice. We can do it with practice. All right, so now I'm going to put... Ellipse always starts with x. So x plus 3 squared plus y minus 1 squared equals 1. The tricky part about an ellipse is going to be where the a squared goes. So look at the vertices. What's changing in the vertices, the x or the y? The y. So where should the a squared go? Underneath the y. So 25 is going to go here. 16 is going to go there.
Wait, how did you know that?
So I look at the vertices. You always want to look at either the vertices or the foci. Because those two go along the same axis, right? And so whatever's changing is the variable it goes under. So since the y's were changing, the a squared goes under the y. Do you want me to say that again, Dakota? So I go to the vertices or the foci, whichever one of the two I have, because I'll have one of them. And so I look, and so whichever variable is changing, so the y is the value that changed, that's the value that's the variable that the a goes under. So a went under the y squared value. If there's time, we'll come back and we'll do another ellipse, but let's get 2 hyperbolas in. Are hyperbolas and ellipses very different? No. What's different about their equations? Subtraction. And the other big difference is the a and b don't switch, but the x and y switch. The a squared's always first. It's dependent on whether the x is first or the y is first. So otherwise, a lot of the work is going to be similar. So let's do this one. So again, and I don't know that I'm not going to use the graph unless we need it. I would put the vertices next to each other. So I'd say -7, 3, and -1, 3. And the foci are -9, 3, and 1, 3. And for a hyperbola, they'll always give you the vertice and the foci. because those other points don't have a special name, and so they're not going to throw those out there for you. Those are something that we graph ourselves. This, I don't know that you're going to come up with the center just by looking at it, unless you're doing some math in your head, which is fine, because the 3 is what's the same in all of them. So I know the center is going to have a 3 as my K value or my Y value. But let's just use a midpoint formula. Does it matter whether I do the midpoint for the vertices or the foci? No, because the center is the midpoint for all of those pairs. So just pick whichever one you want. I'm just going to pick the vertices. So -7 minus 1 divided by 2. 3 plus 3 divided by 2. So the center is -4, 3. Okay. The good thing is here, the vertices are still tied with the same variable. They're tied with A, B, or C? A. The foci are tied with C. So I have, or I'll be able to figure out my A. Whoops. I'll be able to figure out my C. All right, so I'm going to look at what's changing. So I'm going to look at, I don't know how I like this laser thing. I'm going to look at -4 and -1, or -4 and -7. It's the difference between those. What? I thought you said 8 at first. Yes, 3 is the difference. Oh no, I don't know what that popped up was. So my A is 3. Again, if that's hard for you to visualize like that, you could do -7, 3, and -4, 3, and just say, okay, I need to do -7 minus -4. That gets you your 3 or -3, and then you square it. And so it's 9. So I look at my covertices. No, those covertices, that's just my C. Sorry. So my foci to get my C value. So let's see, the 3 is all the same. So to go from -4 to -9, what's the difference between those? 5. So -9, 3, -4, 3. It's -9 minus -4. So it's 5, -5. It doesn't matter which because you're going to square it. Pen's going to take some getting used to. Are we ready to write our equation?
No.
No, I need b squared. So I'm going to say 25 equals 9, good, plus b squared. B squared is equal to 16. Remember, you don't have to solve for b because you don't really need b. Now we're ready to write our equation. Oh, but before I start, I got to figure out which comes first. How'd you know x?
Because it's horizontal.
How'd you know it's horizontal?
Because the vertices change.
So in the vertices, the x value is what changed. So I agree that x is going to come first. It is horizontal. See if I can fit it down here. So you're going to have x. Center is -4, so it becomes +4 squared. Over a always comes first. 9 minus y minus 3 squared over b squared is 16 equals 1.
This is crazy.
What do you think she's going to feel that she missed it?
She's gonna cry.
It's okay, Addison. We're with
No,
you.
It's not, Addison.
All right, let's try another one. So another hyperbola. And I don't know why I didn't write the vertices like this. So 6, -2, 6, 4. And the foci, 6, 7, 6, -5. Do you want to try it first before I do it?
I already forget. It's like so confusing to me. Like just seeing you write all the different numbers up there.
No, there ain't no way I can do this.
Let's have you try it on your own.
Like I'm really so lost.
So find the center. Think about whether you're going to find your A, B, and C. Just take it a little chunk at a time.
It's only doing faster. Yep, I'm lost.
Do you guys agree with the center of 6, 1? Okay. So I'm going to start finding my A and my C. So I'm comparing this and this. So it looks like my A is going to be 3. So A squared is 9. I'm going to compare these two. So it looks like my my C. Like there's no back button. C is 6. So C squared is 36. Are we okay with that?
Yeah.
Okay, I gotta find B squared. So we're gonna say 36 is equal to 9 plus B squared. So B squared is equal to, what is that, 25? 27? Distractions off today. Okay, alright, so I feel like I'm on the home stretch. I gotta figure out what goes first, my x squared or my y squared. I know that A squared is gonna go first. So I look up to my vertices. Y changes. So y goes first. So y minus 1 squared minus x minus 6 squared. I could see that maybe tripping us up. A always goes first. 9, 27. If you got it all except the final equation because maybe you had things in the wrong spot. Yes? Thumbs up.
I just forgot to do the final equation. Got to it.
Were you close?
Yeah.
No.
Can I help you with something about it?
Everything.
Well, where would you like me to start?
I didn't get the A right.
Okay, so do you want me to look at it again?
No. I get it now, but
Okay. Do you need me to go over any of it again?
no.
Are you sure?
Yeah.
All right, let's do one more ellipse. I don't know how you make a new. There we go. All right, so let's do an ellipse. And they have to tell you what you're writing. Let's do. Yep, they do have to tell you. So an ellipse with vertices 1, 1. This is kind of similar to one we've done, but I've committed now. 1, 1, and 7, 1, and co-vertices at 4, -1, and 4, 3. Try that one on your own. It's now an ellipse. Similar, but it's an ellipse. Find the center, your a squared and your b squared. See if you can write your equation. All right, would you agree with the center 4, 1? Okay. So now I'm going to try and find the A because the vertices are tied to A. So I'm going to compare 4, 1 or 7, 1. What do you think the A is?
4. 3.
Or A is 3. So A squared is 9. Then co-vertices are tied to B. Oh, good. I don't even have to do the A squared, B squared thing. So I'm going to compare. Okay, so 4 staying the same. So I'm going to compare this one. B is 2. Whoops. So B squared is 4. All right, so I'm going to have X is always first for an ellipse. X minus 4 and Y minus 1. I just have to decide which comes first, A or B.
B.
So I look at my vertices. Which change, the X or the Y?
Or
The X, that means the A goes underneath X.
Oh, it's a covertesy. It's like
All right, your homework is page 655. You're going to do 13, 14, and then the next two are parabolas, 15, 16. So then you're going to do 17 and 20 after that. I will not collect that, but I strongly suggest that you do it. And if we even have to go over every single one tomorrow, I'd be glad to. You can pack up your stuff.
I think I'm gonna cry.